morning, good afternoon, good evening. Welcome back to chapter 15. We're talking about plate tectonics. We're talking about how the continents move around. Remember in the last video we were talking about how you're supposed to imagine how the continents move. You're supposed to imagine a pool, a swimming pool, with a bunch of floats on the surface of the water. And over the course of the day you would see those floats move around. And as those floats move around, they will hit each other, they'll run into each other, they'll bounce away, they'll move back and forth. That is what the continents do over the course of tens of millions, hundreds of millions of years. This is referred to as continental drift. Continents move. In the history of multicellular life, remember multicellular life is about 2-ish billion years old. The Earth's land masses have formed a supercontinent 3 different times. The oldest one was called Rodinia, and it was about 1.1 billion years ago, or 1,100 million years ago, to about 750 million years ago. That's how long it was together, so about 400 million years it was together. Drifted apart, came back together again about 100 million years later, and stayed together for about 60 million years this time, not very long, only 60 million years. Pannosia, it was called, and then it broke apart and drifted apart for about another 250 million years, and came back together to make this thing called Pangaea. And Pangaea stayed together for, again, about 60 million years. The reason why this is important is what... I need a pen. I want you to imagine a continent that is 6 inches on a side. And let's imagine that we have 4 of them. All right? 4 continents that are 6 inches on a side. So there's 1, 2, 3, 4. Here's my 4 continents that are 6 inches on a side. Well, if this is 6 inches, and that's 6 inches, then what is the circumference, what is the perimeter of one block, one continent? Well, it's 2 feet. 1 foot, 2 feet. So all of these, the circumference of all of these are 2 feet. So what is my total coastline? Because what is the edge of the continent called? The edge of the continent is a coast. My total coastline is 2, 4, 6, 8 feet. The reason why that's important is because most living things are found on the coast. Most living things in the water are found around the coast because that's where you get the influx of resources from land. Most land things are found near the coast because you get the bounty from the sea. So most life is found on the coast. If I have 8 feet of total coastline, that means I can have 8 feet of living things. Now let's think about this thing called Pangaea, where all of the continents come together in one big chunk in the center. And now let's put together our 4 continents again. Here's my first one. And there's my second one. And my third one. And my fourth one. And remember, it used to be that this was all ocean between my big continents. But now what's happened here? This is not ocean anymore. This is all land. This is all one big continent. So now what is my total coastline? I had 8 feet of coastline, 2 feet around each continent, but I've lost all of this center section. So this is, remember, 6 inches. So this is 1 foot, 1 foot, 1 foot, 1 foot. What is now my total coastline now that all of these things have come together? My total coastline is now 4 feet. I used to have 8 feet of coastline, but now I have 4 feet of coastline. If most living things are found around the coast, what has now happened to the number of living things that I have on this now huge supercontinent? Well, if I have half as much coastline, then the simple math says I should have half as much living things. Well, if you've lost half of all the living things, that's called a mass extinction. Every time the continents come together, you get another mass extinction. And it's happened at least 3 times in the 1.5 billion years of the age of eukaryotic life, of the age of multicellular eukaryotic life. Multicellular eukaryotic life means plants, animals, and fungi. Plate tectonics. This shows those different plates. Here's our North American plate. Remember I said that North America is moving this way. It's moving further away from the European plate. The Pacific plate, bunch of different plates. These are all of my pool floats that are all floating around. This is something that I want to show you. See all these red dots? Notice how all of these red dots are located right along these lines? Those red dots are volcanoes. This is called the Ring of Fire. You ever heard of the Ring of Fire? The Ring of Fire is the ring of volcanoes that surrounds the Pacific plate. The Pacific plate is the biggest plate. It is gigantic. The Ring of Fire, all of these volcanoes. This is where we find volcanoes along where plates come together. Plate tectonics. The plates move. If you can't see this on my graphic, again, please make sure you've got the PowerPoints downloaded so you can look at this picture on your own. This shows the end of the Paleozoic and the beginning of the Mesozoic, and we see Pangea. We see all of the continents all grouped together, clumped together right here in this one block at the bottom. At some point, it begins to break up. It breaks up into 2 supercontinents called Laurasia and Gondwana. And if you look really close, we can see some of the geography of present continents. What is this right here? This is Africa, and that's South America. So that makes this Europe, and that makes that North America. If we move from 135 million years ago to about 65 million years ago, we're finally seeing geography that's close to what we recognize today. Europe and North America are still connected here. North and South America aren't connected to each other yet. And India is an island. And then we move to present-day geography, which is what we recognize. We look at the geologic record. We look at the age of fossils to try to piece together the history of the planet of the Earth. We look at the sequence and ages of fossils in the layers of rock to try to figure out how old the planet is and to try to figure out the assemblage of life. What kinds of living things did we start with versus, and how did we get to the living things that we see today? Because the fossils that we see in the layers of rock don't look like living things that we find today. And things that we find today are not found in these fossils in the rocks from millennia and from hundreds of millions of years ago. So where did the present living things come from? Where did the previous living things go? Well, the previous living things, through natural selection, through the course of evolution, gradually changed into things that we see today. Everything alive today had an ancestor alive at that time, but not everything that was alive at that time made it to today. Lots of groups died out, but some had to survive because we have lots of living things today. After the Precambrian era, we're divided into three unequal sections called the Paleozoic, the Mesozoic, and the Cenozoic. You notice how they all have this zoic part in common. What does zo mean? What is zoology? What do you do when you go to the zoo? What are you looking at? You're looking at animals. So zo means animal. Paleo, what does paleo mean? It doesn't just mean old. Paleo means ancient. So Paleozoic is ancient animal. Mesozoic is middle animal. Cenozoic is current animal. The boundaries between these eras, between the Precambrian, the Paleozoic, Mesozoic, and Cenozoic, are marked by mass extinctions. The Paleozoic is our second history in the life of the planet. Paleozoic means ancient animal. The Paleozoic begins with the Cambrian period. It begins with one section, the first section called the Cambrian. Most animal groups alive on the planet today trace their ancestry or can trace their ancestry to this period. Most phyla. Phyla like jellyfish, like starfish, like bugs, like vertebrates, like a bunch of things, can trace their ancestry to this period. They had representatives alive at that time. This period began about 500 million years ago, and about 50 million years after this period begins, plants and fungi begin to colonize land. Remember, there was no life on land until then. There was no life on land. All life was in the ocean.